Okay, this is 2023 trial paper from Kedah, paper 2, question number 4. Given the curve with the equation passing through a stationary point A60. So this is stationary point. We know that at stationary point, dy by dx equals to 0, okay? At stationary point, dy by dx equals to 0. So when we substitute dy dx equals to 0, we will get the value of the x of the turning point. But the turning point is already given. I mean, the stationary point already given. So what we need to do is just find out what is the dy by dx, because we need that to determine what kind of stationary point is that. Is it maximum, minimum, or inflection point? So let's find out dy dx. So we have two terms here that multiply, not two terms, sorry. Yeah, we have u, v, the product of u and v. So the dy dx will be stay v, differentiate the u, plus stay u, differentiate the v. So we just copy the v, negative half x minus 3, raised up to the power of 3. Differentiate the u, negative x become negative 1. Plus, differentiate the stay u is negative x. Differentiate the v, so we bring down the power to the front. Okay, reduce the power by 1. And followed by the inside, when we differentiate it, we'll get half. Okay, and therefore we can simplify it, or we can just leave it because we need the dy dx to find the type of the stationary point by using the tangent sketch method. So we actually, you simplify also can, if don't simplify can as well. So but I choose to factorize. So if I factorize this term, between this term and this term, the common thing that we see is half x minus 3 raised up to the power of 2, the highest common factor. So let's take that out, and inside we will left with another half x minus 3. Okay, as for the second term, I have taken out this whole thing. So what is left behind is just 3 over 2x negative, negative 3 over 2x. Okay, so let's combine it. We have negative half x plus 3, and then minus 3 over 2x. And then negative half minus 3 over 2, we have negative 4 over 2, so negative 2x, so 3 minus 2x. So this is our dy dx. All right, so by right, we use dy dx equals to 0 to get the stationary point, since we already have, okay, we already have 6, 0. So we need to test this point by using the graph sketching method. Okay, the tangent sketch method, yeah, which means we create a table. To test a point, we need to test the point before and after. Okay, so we divide. So we get the 6 here, and before 6 is 5. This is the value of x. Before after 6 is 7. And the value of dy by dx, when it is 6, we get 0. That is the reason dy dx equals to 0. From there, we get 6. But what if it is 5? So for that, we're going to use the calculator. Let's key in this one. So we have half, which is 0.5 square. So let's put the bracket, x over 2. So the x value is 5. So 5 over 2 minus 3, the whole thing squared, multiply with 3 minus 2 times the x value, which is 5. So we got negative 1 and 3 over 4. Negative 1 and 3 over 4. We then check if the x value is 7. So we just change the value where we key in 5 just now, change to 7, and let's see what's the answer that we get. We got -2 and 3/4. Okay. If you're not sure about the 6, you can try using a calculator. At the 6, 7, the digit 7, you replace with 6 because that is where the x is. Definitely you get 0. Okay, so that is the value of dy dx, and then we know that dy dx is actually the tangent, so we sketch of the tangent. Okay, sketch of tangent. When it is 0, it's horizontal line. When it's negative, it's going downhill, both going downhill. And then from here, you can sketch the graph. Sketch of graph. Going downhill, then go flat and downhill again. So from here, it is very obvious. We can make a conclusion. A60 is an inflection point. Inflection point. Titik lekuk balas. Okay? Titik lekuk balas. Okay? So that is for part A. Now, as for part B, there is a small change in x. Now, for part B, there is small change in x by 1% when x equals to 2. So when your x equals to 2, the changes is 1%. So the small change is 1% of the value of 2. Therefore, it is 0.02. We just need to get the del x here, because according to the fourth application, we know that del y by del x is approximately equivalent to dy by dx. And what is dy by dx? We have found the dy by dx here. That is half x minus 3, and then square 3 minus 2x. That is when x equals to 2. So when x equals to 2, our dy dx equivalent to half times 2 minus 3, square it, and then 3 minus 2 times 2. So over here, you can use the calculator. So 1 minus 3, we got -2 squared 4. And then 3 minus 4, which is -1. So we have -4, yeah? Okay, now we put this in del y, approximately equivalent to the dy by dx times with our del x. Therefore, del y approximately equivalent to -4 times with 0.02. So that is -0.08. Okay, let's see, have we answered the question? Find the corresponding percentage change in y. Okay, so our y, the change of y is you reduce by 0.08. Okay, so what is the original y? Because the percentage of y must be from the original y. So let's find out the original y. So the function is -x, half x minus 3. So -x multiply with half x minus 3 raised up to the power of 3. Originally, x is 2. So we have -2 multiply with -2 to the power of 3, so -8. So we have +16. And therefore, the percentage of change, the percentage change in y, yeah? The percentage change in y will be, we take the positive value, yeah? Because the change either increase or reduce. Doesn't really matter when we use it to calculate the percentage. So times with 100%. This one, let's just use the calculator. So 0.08 divided by 16, and then we times with 100. So we got 0.5%. That's the answer. To be safe, I think we just add y reduced by 0.5%. All right, that's it.